Good afternoon, everyone. Thank you for joining us today for Mr. Tom McDermott's presentation today on WRT-1040, application of digital engineering measures. As you all know, Tom is a leader, educator, innovator in multiple technology fields. He's also our very own CTO at CERC and a consultant specializing in strategic planning for uncertain environments. He studied systems engineering, systems thinking, organizational dynamics, and the nature of complex human social technical systems. He has over 30 years of experience and background in technical and management disciplines, including over 15 years at Georgia Tech and 18 years with Lockheed. But we are very, very happy to have him with us. So over to you, Tom.
Thanks, Jan. So I'm going to talk to you about this digital engineering measurement framework. It's interesting piece of CERC work in terms of transition. So I'm going to mostly talk about the transition of this work and how we got there, which created the first digital engineering measurement framework, which is published out now. So if you haven't downloaded that and used it yet, part of this is please use it, start measuring in your digital engineering, because we're not going to really understand the return on investment of this transition until people start measuring stuff. That's the question that we always got was, can you just tell me what my return is going to be with this investment in the tools? And like, no, you know, that's a long-term lagging indicator. First, we have to figure out how much money you're saving in this activity or this process by converting to digital engineering. So, so this was sponsored by Phil Zimmerman. I think Tracy Gilbert, who's here, was probably the one that interacted with us most on a daily basis in here. I led this project with Alejandro Salado and Eileen Van Aken at Virginia Tech. But most of this work is from Caitlin Henderson, who was a PhD student at Virginia Tech, all the analytical work she did. So we would not be here without Caitlin today. All right, so here's the end. The digital engineering measurement framework started in 2020 as a AIA project plan to address digital engineering measures, Aircraft Industries Association. So they decided we would sponsor an industry working group. And so when we did this, we pulled together AIA and INCOSE and NDIA and the CERC and said, yeah, we need to do this. We have all this research. So we've characterized this space. Now we need to get it into a form that other people can use. We teamed with the Practical Software and Systems Measurement organization, which is led by Dr. Cheryl Jones up at Army, and has had a long history, and as well as wrote the ISO standard on software measurement. Right. So we had a framework. You good? So we had a framework to work from that says this is how we actually define measures out of this process, and that resulted in a draft that came out in January for comment, which went through a few iterations and then finally became version 1.1 formal release in May of this past year. So this framework is a few months old. We need to start using it and getting practice out of it. And I'll show you at the end, there's a whole bunch of organizations that became involved in this, both DoD and commercial. So where'd this start? So back when we first started this and we started asking the question, return on investment in digital engineering, we're like, there's not any way we can even answer this question. Nobody has any experience at all. You know, how do we even start to characterize that? And so we started with a survey, and the survey was built from the INCOSE Digital Engineering Capability Maturity Model, or matrix, that they called it at the time. And so what we did is we ended up releasing a survey to people that was based on this maturity model. And I'll go into more detail later on the survey. But this has been used and reused, although it's not really necessarily formal yet. It was developed by NASA and the Aerospace Corporation. It has become the Air Force standard now for measuring their program level readiness to do digital engineering. And it's a typical maturity model. So you have a stage 0 through stage 4, and you're self-assessing your level of capability around all of these things that would have to do with digital modeling, like collaboration or ability to collaborate around models. So what we did in the survey is we said, if you rate your state of readiness using a question that was linked to stage 4. So we got, of course, not great results because not that many people are stage 4, but it was very informative. So as we worked through the process, the other thing we did is we asked, I think it's on the next slide, we asked a set of text-based questions. And that turned out to be a godsend because we asked questions like, what are the enablers or barriers to digital engineering? What are the most important measurements, things like that. We got a text corpus from about 170 people in the space that Caitlin could link to her research, which was looking at text analytics in the publication space. So that turned out to be really good. So I'll jump back a chart. This stuff is still on our website. So if you want to really read the report on the survey and the initial metrics work that came out of it, here's the link on our website to go see that stuff collected. I've been asked multiple times, are you going to repeat this survey? It's getting near to the time. So if there's a sponsor out there, it would be good to go update this survey probably before too long, particularly looking broader than the system engineering field, which is mostly what we targeted in the beginning. So this was the answer that came out of it. This is a normalized scale on all these dimensions. So each one of these ratings, quantitative ratings, was basically a 4-point Likert scale. Rate yourself from not good to okay to good to really good in these areas. And you can see on the red that there's not a whole lot of green on here. So most people would be rating themselves as not doing very well yet. And so as we went through this process, and I'm not going through all the details of it, I'm going to point to this one that's in the middle here that says modeling produces measurable improvements. Generally, people said yes. I have consistent means metrics for measuring my modeling. Big time no. So, that kind of led us to the state of the practice in their space. And so when we started looking at this data and just sort of looking at the demographics of the survey, we surveyed government, industry, commercial, we surveyed different sizes of organizations, we surveyed different amount of times that people had been investing in digital engineering. And so what we kind of saw was this, I perceive that metrics that is going to have a benefit, but I'm actually measuring the benefit as being very consistent across all these demographics, including amount of time. So people were not improving over time in their measurement of their digital engineering process. Well, this is a problem, right? So that's what we really learned about this. So, the answer to that is we need to be telling people what to measure. And that was kind of the outcome of it. So enter Caitlin. So Caitlin went through 847 papers that talk about model-based system engineering. She found 360 that mentioned the benefits. She characterized what those benefits were in those 360 papers. And so she found out of that list, 236 that perceived gains from it, 27 that observed them, but only 2 at this point in time that had actually measured a gain from digital engineering. This was open literature. So we combined this with the survey. And so it was really informative to us at the time. And, these were what she found. So there were 48 specific benefits isolated from our survey data and the literature search that could be targeted as a benefit that you could measure and improve your performance over time. And so the most important ones of these are the most frequently cited were increased traceability from models, reducing your defects and errors, reducing time, improve consistency of processes, reuse, higher level support for automation, and better communication and information sharing or knowledge transfer. So a lot of these things were things that we've always thought would be. And so they became cited. But again, we didn't have anybody that was measuring any of these things at that point in time. So a lot of these things like defects, these are measurable. Why not start measuring them? So that was kind of where we ended. At the same time, we derived out of the survey 36 adoption metrics. So organizational adoption of digital engineering. And so availability and maturity of your methods and tools, training. This interesting one, willingness to use the tools, because every time you got to generate a piece of paper for somebody, you're destroying the efficiency of your digital transformation, especially in this space, right? So that was one of these things that became what we called a primary benefit that had to be looked at. So we took that and we summarized out of that the initial top DE metrics areas organized by quality, velocity or agility, user experience, which you have to measure with digital tools because that's people's willingness to use them. Knowledge transfer, which is really interesting because nobody else really measures knowledge transfer in their digital transformation, but with models you can do it. They capture the knowledge, right? So this was a unique benefit of digital engineering, and then these adoption measures. And so we were able to rank these things coming in and take them out of the survey. So then Caitlin got busy with the next level. And so we built a causal model. We built a causal model relating the things that were primary benefits, which you would call a primary benefit is a thing that I can do and I can directly measure, down through all of the secondary benefits that lead down to things like, in the end, cost or return, but you understand cost and return is something that's lagging. You need to find things that are more in the middle of this causal model that would be more leading indicators, like am I actually finding requirements defects or something like that in the process. The gold ones were the adoption measures. It's clear on this chart, but you'll kind of note that the adoption measures form a big causal loop, right? You have to have the adoption things fed back into the process in order to do that. So we came out of this process with these 8 primary measures that were the initial causal links between them. Higher level support for automation, earlier verification and validation, reusability, better traceability, better testing, better accessibility of information and knowledge, better support for integration, and then the multiple viewpoints of the model, which improve multidisciplinary knowledge sharing. So these were the top of the models, and then we took this into the process. So where do we go next is we start trying to link these together in what you might call a metrics flow. So in order to understand better accessibility out of information, you need to measure the maturity of your digital engineering infrastructure or evaluate it some way. You need to be able to look at the data, your authoritative source of truth, and do you actually have the data and models that would be accessible? And then you've got to actually look at the leading indicator, which is people willing to use the tool, right? You got to measure how many of your people are going in and moving to a digital process. When you have that, then you can look at the primary causal benefit, which is effort, reduction in effort, which leads to reduced time. And then in the long term, reduce cost and reduce schedule. And so these causal chains were really helpful in helping us in the measurement framework because, you know, even though all the program offices said, just tell me how much money it's going to save me, we're like, we'll never have any data to do that if we don't tell you to go start measuring the things that would cause cost to be reduced. So we took this research, and this is kind of the area where transition is really helpful into this process. So the practical software measures process is a very disciplined process that starts with information needs. So what's the piece of information I need to know? Is digital engineering saving me time? That would be a piece of information that I need to know. And then that leads down from there into, can you define an indicator? So cycle time, right? There's an indicator that you could possibly measure in that space. And then if you work your way down from there, then there is a set of base measures and derived measures that would actually drive a specification. And underlying that, there's a set of attributes that you would want to catch. So this is a really disciplined process. It's captured in what's known as an ICM table. And so we met as a big community. Everybody from all the different industries brought their favorite indicators and metrics, and then we started banging them against this causal model and deciding what were the most important measures for us to publish out, trying to do this in the beginning. And along this process, we were trying to isolate digital and model-based system engineering, right? In the end, it's software. You're measuring things like defects like you would software, but it's important in digital engineering that you're finding those defects earlier than you would have before the software is produced. That's the value of the model. So we tried to isolate those types of characteristics out. So as part of that, we kind of had to define these general linking models. So if you think of probably the two main things you want to measure up front, it's your defects and your cycle time. And the general idea here is you can be finding and eliminating anomalies, we ended up calling them, or defects, earlier in the development process if you're using modeling and simulation, much earlier. And then ideally, if you're digitizing everything, then what you should see is the results of that not being an action item that takes 2 months to resolve. It should take a day to resolve. How easy is it to make changes? And so you can start tracking this process of iterations through my development process to iterations through the integration process and through iterations to the formal releases. And so anything that escapes to a formal release out of your digital engineering process should be rare at that point in time, because you've really worked it off. The general that was head of A35 at the time, he said this really well. He said, just tell me that digital engineering is causing me to have no more than 4 releases into flight test on any block. We're doing 12 or to 15 right now, right? So, that's the true measure of value. And again, how do you calculate that out? So you can see this relationship between finding things earlier and reductions in cycle time. You don't have multiple iterations that are destroying your cycle time. And then you should be able to build up a rhythm. So that's kind of a good thing. And so then you can build out a specification. And this is the measurement information model for what we came to call anomalies instead of defects, because we were trying to distinguish it a little bit from the software community. And so you can see in the indicator over here that you should be seeing your finding curve shift to the left from what you used to see, right? That's what you should be seeing if you're being effective in your digital engineering. And then, here's a sample indicator with how do you measure it. And then if you trace this down to things, and I can't even read my slide anymore, but if you trace it down, it's the number of anomalies that originate in the process, the number that you detect, and the number you resolve that feed into that. And then you can start tracking containment, which is, did I resolve them before the next iteration, which is the really important thing with the model, is not having those things escape from one iteration to the next. So this is the way we derive these specifications. And this is what a specification ends up looking like in the document. This is one for traceability, right? So the other cool thing you can do with models, the tools inherently do traceability for you. You have these dependency graphs that come out of your modeling environment, and you can design a system where you can actually measure traceability and untraced things in your models. And so this is really nice out of the tool. So you can see in each one of these specifications, you have a description, you have the relevant terms, you have the information need, and then you have the base and drive measures, which are the really important things, and maybe equation. Then we add in a sample of the indicators, and then guidance on how you analyze the data and make decisions about it. And so each one of these specifications is laid out like this. So in the body of work in PSM, psmsc.com, there's the practical software measures framework, which then derived into the continuous iterative development measurement framework, which now has derived into the digital engineering measurement framework. So all of this work kind of links together, and it follows the same format. One thing I'll say is, because we don't have programs do any of this yet, these are not real indicator examples. It would be nice if we were able to have somebody give us a real indicator example from something they did, but we're just not finding that maturity in the process yet. So So that's what we have to get to. So coming out of that, there were 8 initial measures. We understood it to be 8, but we wanted to sort of get the fundamental ones out into the field based on the causal model, so people would start building their body of knowledge around this. So the top 3 of these are really related to the models. Architectural completeness and volatility. This really has to do with untraced model elements. And so all of these things, they kind of end up down in this sort of definition of what you call a model element. We called it that because we have to understand that every modeling tool that you go to is going to define a model element differently. So, the problem right now is you're not going to be able to be real consistent between modeling tools because they define these things, whether it's packages or classes or functions or, everybody's sort of doing a different thing. We wanted to be generic, but they all offer you the ability to find missing dependencies in your modeling elements. And that becomes really important. And you can drive that up to what we call architectural completeness or functional completeness. And you can measure that over time. So you should be able to measure your ability to build out a model that is more complete understanding of your system than what you had in the past. Model traceability is just that deeper thing. So you actually start looking at the dependencies and untraced dependencies. And then this product size. So product size, you can go off and you can start calculating in terms of model elements, how big your product is versus plan. We don't have a model size estimation tool yet, right? So we still need to do some work on estimating and cost, COCOMO for models, if you want to call it that. So we don't know what to base that on, but we will be able to measure size of this process as people develop those processes. 2 on anomalies. So anomalies originated, detected, and resolved. It's down on the bottom, as well as anomalies open, which really looks at this containment. So you ought to be able to see your open things closing further. And then adaptability and rework. And so you should be doing rework in the model, not in your product, right? And so you want to actually see that adaptability and rework happening. And adaptability, we called it adaptability because in the modeling phase, you may want to do change, right? You may want to do adaptability in that phase and not just call it rework. So those were the top 6. And then we had 3 more. Actually, there were 9 that came out. Product automation. So we were actually looking at the ability to generate decision artifacts out of the tools and whether you're automating those or not out of the tools and whether you're seeing those artifacts being generated out versus plan. Deployment lead time, which is just measuring iteration to iteration, what your cycle times are. So this is very close to the agile side of things because model development should be agile. But are you actually accomplishing your planned cycle times? And then one that came up out of experience. So this runtime performance was actually the only real metric that we took in. So this was from Volkswagen. And so what they found as their digital engineering strategy is it became important on how fast you could execute these models. You think of fluid dynamics and things like that. Sometimes these models take days to run and you're going to reduce your effectiveness of use of models is every time you make a change, it takes you a day or a week or so to rerun the models. And so they suggested that we include a runtime performance, which is also kind of a unique measure for digital engineering. So that's the initial set. We know this is not the final set. You don't see cost in here, right? Everybody still wants cost, but we didn't think you could start with cost. So there's some other things that have to come into the equation. So just to point out the team. So the authors of this document were Cheryl Jones from PSM, Joe Bradley, a wonderful volunteer working with the Navy, but he did this all as a volunteer thing. Jeff Draper from Harris, myself, and then Paul Janis, who's also been working with the PSM group. And then we had all of these people from all these organizations bring in their experience and their things that they were looking at doing. And some of it was global. It was less global than maybe it could have been, but we've captured the community in it. So really a community effort. Next step, so we've got a couple things to do. So INCOSE published a System Engineering Leading Indicators Guide some years ago, Donna Rhodes and Gary Rodler. This measures important things like review action items. So we haven't gone back and updated the System Engineering Leading Indicators Guide based on digital measurement yet. So that's a task that we'll be doing out of INCOSE hopefully in the next year. But we did identify across all the system engineering indicators where these digital measurements would apply. So that was part of our reports. That's work to do. We haven't got much validation. So we validated the model against one program, which is the Navy submarine, the swiftest program. And so they've actually done a nice body of work where they've measured their requirements modeling first indoors and then in MBSE. And they've been able to show the gradual improvement from nothing to doors to MBSE. And so they're realizing things like an 18% reduction in their system engineering hours using modeling in this process. So we had one body of evidence that we could validate our causal model against when we went through this, but there was only one that we could have access to. And I'm not sure that there was actually more than one. And so the next thing is where to go from here. And I'm not going to go through this, but we kicked off version 2 for the measurement framework at the NDIA conference. So the plan is to go ahead and start working on version 2, collect people's experience on the measures we have, but also start working on these key measures that would be things like cost and also on enterprise. So everything in the framework right now is a project level measure. We don't have that mapped up to enterprise level measures yet. And so we expect to release a version 2 that has, I think we had identified around 18 of them initially. Maybe we'll get up to 18 in the next generation of the spec. We're going to probably do a half day on this at INCOSE IW in January with the community. And so if any of you have experience, want to work on this, like I said at NDIA, some of us authors in the first time are getting a little bit tired. We'd love to have some help. So please join us and help us do this development. I think that's it. Okay.
I know you got this.
Tracy? So we had a couple of tool vendors involved, but not a general participation from tool vendors. So yeah, I think we're specifically going to try and adopt the tool vendors because in the end, all these things have to come out of the tools, right? I mean, or nobody's going to do it. So, and families of tools, right? You're not necessarily going to track defects in the same tool you're tracking traceability in, right? It's a larger process. Jeff?
Two things. One, help me understand the response. Was it primarily government program offices, OEMs, subs, a mix, academia? What was the blend of input that you see that impact?
So all of the input into the specification that came out was industry, informed by academia. We had government oversight, so we had folks from ARNI involved in this process, and but the metrics themselves all came from people in industry who brought the stuff they were trying to do.
They rated their business because
so Bob Shire, who a lot of you I think know, brought the architectural completeness metric in based on their experience on the T7 program. he said, we figured we tried to do this. And so we really understand this needs to be done. So and Richard Halligan brought 2 of the metrics in. He's from Volkswagen. So he took his experience on the digital engineering of Volkswagen. And he brought 2 specifications in for us that we end up using. So, you know, we got people that were they were experimenting with measurement in their companies to come in and do this in almost all the cases, really. So that's where the data has come from.
Great work. The one thing I didn't hear in the conversation though is was that ever explored, or is that just too far down the road? Because fifth left cycle time, capability, delivery, it feels like that needs to be.
It's probably captured in automation right now. In other words, you got to automate your test for models, like you have to automate it for software and other things. But I don't know that we looked at verification validation specific things yet in that process. So again, I mean, these are areas where love to have people come in and say, these are the next level that we got to look at. Okay. Yes.
Tom, maybe I missed this part, but have you looked into unintended consequences or undesirable consequences? So it's transformation. So in addition to all the benefits, have you looked at maybe there are potential downsides? It's perceived by the stakeholders.
So we didn't categorize unintended consequences, although there are those in the database. Specifically in adoption, we looked at enablers, barriers, and change. So we asked those 3 sets of questions, which came up with a lot of unintended consequences. But we didn't necessarily turn those into measures. And we didn't try and categorize them as the dangers of transformation yet.
Do you think there could be some value to looking into that to maybe better facilitate the transformation?
Probably, if you think so, there probably is. Yeah. I mean, I think we have a database, survey database that we could update that has this kind of language in it. Okay. I think I'm about out of time. Who's reading? They're just comments.
Yeah, they're just getting ready.
Okay.
So you get a comparison between literature review and survey. I think the last category was adoption, but there was no assessments from the literature review. Was that because it wasn't looked for, or because it didn't exist?
So we did Caitlin before she graduated. I wish she would come work for us, but I don't think it's going to happen. She did the literature review on adoption under the system engineering modernization program. So what we did is she's categorized 600 and something lessons learned statements out of the literature review, which a lot of it has to do with adoption. So that's the next project we'll talk about later this afternoon. All open source publications, right? And, you know, one of the challenges we have as a CERC is, in general, industries not bringing their proprietary modeling methods into our studies. Open survey, they'll talk about things, but they're not going to walk us through, we did this and we discovered that, right? Yep. And I think industry generally thinks, particularly in our domain, that their ability to do digital engineering is a competitive advantage. So this is a general problem area that we're going to have, the government's going to have. You know, we understand that. Okay, I think we're out of time.